students. So today let us start the last topic of wave optics based on polarization. We are going to study Malu's law today. Okay. In the last class we studied that how the polarizer actually is making a plain polarized wave out of unpolarized wave. In unpolarized wave, if suppose we say that intensity is I. So after passing through polarizer, we saw that the intensity becomes I by 2. From there only the Malu's law starts. See what Malu's law says. So if you see that this one is here the unpolarized light. This is unpolarized light which is passing through the polarizer. This is polarizer. Okay. So here the intensity which comes out. Here I have taken that as this unpolarized wave. In this one, vibration in electric field is along y-axis as well as z-axis. Okay, but when it passes through this polarizer, this intensity which is coming out, in this one electric field is oscillating only along y-axis. Okay, and the intensity has become half. So that's the polarizer. What Malu's law says, if suppose that we want to decrease the intensity further. Okay, so then we are going to use analyzers. These are polarizers only, but we are calling them as analyzers. Okay. And this analyzer, what we have done with that one, the axis of this analyzer is making an angle theta with the axis of the previous polarizer. Okay. Here axis of the polarizer we can say is along y-axis. So here with y-axis, this angle is made theta by axis of the analyzer. Okay. So then what is the intensity coming out? Intensity coming out according to Malu's, it is equal to the intensity of incoming wave into cos square theta. This theta is what? The angle made by the axis of the analyzer with the axis of the previous analyzer or polarizer. Okay, so here it becomes I2 equal to I1 cos square theta. Now the next one, if suppose another analyzer I am keeping which is horizontal. Okay, this is horizontal and the angle of the axis of this polarizer or analyzer is 90 minus theta with the previous one. Okay, it is 90 minus theta with the previous one. So then what is the intensity coming? Intensity here is intensity previously into cos square angle over here which is 90 minus theta. So what is this I3? Let's check here. I3 is I2 cos square 90 minus theta means sin square theta. I2 is what? Say I1 cos square theta. I1 cos square theta sin square theta. Now what is I1? I1 is actually I by 2. So I by 2 cos square theta sin square theta. If we can write it in another way, I would be multiplying here with 4 and dividing it with 4. This is cos square theta sin square theta. So what I can write this as? This I can write as cos theta sin theta whole square. So if we write cos theta and sin theta whole square over here and take this one inside, this 4 inside. So what's going to come? Let's check. The form that we are going to get in this one is I by 8 equal to 2 sin theta cos theta whole square. I by 8, this becomes 2 sin theta cos theta whole square. So this is sin 2 theta. So this is I by 8. This is sin square 2 theta. That is I3. Okay. So if suppose one analyzer is directly placed perpendicular to the previous one. Suppose this is one polarizer. From here, intensity is coming along y as well as z axis, or rather the electric field is oscillating along y as well as z axis. Okay. And here in this one, we are having a polarizer, and here the intensity is coming only along y axis. Okay. So if this intensity is I and this intensity is I by 2, and the next polarizer is directly placed horizontally like this, with this as the opening. Then in this case you can see that the axis of this polarizer is making 90 degree with this one. So in this case, what intensity will come out? We will say I by 2, this intensity, into cos square 90 degree. In this one, what intensity will come out? 0. Okay, so this is what we have to learn as far as Malu's law is concerned. Okay, let us discuss about polarization with scattering also, but that is actually a board point of view. Okay, that is not according to the competitive point of view, so that I am not discussing right now. Okay, that's all for now.